All right. Thanks everybody for setting up your notes. I'd like you to make your notes look like this. Now, I want you to notice that we're going to talk about the inverse trig functions. Okay, so this is the key to grasping what we're talking about today, that we're talking about inverse functions. So before we even get into the sine and cosine, I don't know if you guys remember or not, but we talked about selling cookies over in Italy, right? We said, hey, chocolate chip cookies, maybe they don't know about them, how good they are. And so let's say X stands for the cookies, okay, so cookies, and Y stands for the amount of money that we make. Okay, now I know that's not the euro symbol, but we're going to sell them in dollars. And we're going to charge, like town and country prices. So you sell one cookie, you make $2. And you sell two cookies, you make $4. You sell three cookies, you make $6. Obviously this is a y equals 2x linear function, right? Well, if you want the inverse, you want x to represent the amount of money. So you know how much money you have. You just want to figure out how many cookies you sold, right? So you notice the x and y switches, just as a reminder, when we're looking for an inverse, the x and y switch, right? And so like if you had $2, you must have sold one cookie. If you had $4, you sold two cookies. $6, you sold three cookies. And you can see that the equation is y equals 1/2 x, right? You don't need any fancy business with this, but I want to remind you that the process looks like this. So step one, to find the inverse, you switch the x and the y, right? So you make it x equals 2y. And then step two is you solve for y by, whatever method you can do to solve for y. And so we end up with, 1/2 x here. This is just algebra, right? Algebra, you just divide by 2. So what's going on here? Today, we're going to talk about the inverse sine function, and it looks like this. Sine with a little -1 for an exponent. That means the inverse sine. And we're going to talk about the inverse cosine function. So back over here, just as a reminder, like if we called this f of x, right here, the y is equal to f of x, the inverse is going to be f with a little -1. That's the inverse notation, okay? So if this is our main focus, what kind of challenges do we have, right? Well, we're going to need a domain restriction. And I want to have you guys understand why we need that domain restriction, all right? So let's go back over here to our easy example with cookies. And if you graph the line y equals 2x, it's a constantly increasing function. It just looks like that, right? And I have a domain restriction here because I have a real world problem. You can't sell negative cookies, right? So a constantly increasing function is what we refer to, or is also known as, a one-to-one function. So if I drew a horizontal line on here, it's only going to cross in one spot. The horizontal line, this is called the horizontal line test. That means that it's a one-to-one function. That means that the inverse over here is also a function. So, the inverse might look like this, y equals 1/2 x. And that's wonderful because if you know how much money you have, there's only one option for how many cookies you sold. If there was more than one option, there might be some fraud. We talked about that, So what's going on, right? The function's not giving us one answer back here. So that's why we need domain restrictions, because the sine function and the cosine function are not one-to-one functions. They are not constantly increasing or constantly decreasing. The fancy word for that is monotonic. So let's look, if you guys would, open up, in your Google Classroom, open up that attached file right there about sine and cosine graphs. And I've put a little domain restriction on this. Now you can't really see it because my window is set up from -3 pi to +3 pi. So the first thing I'd like you to try to do is zoom out a little bit, so you can see that, it stops. It doesn't, keep on going, and that's because of the lower bound that I've created and an upper bound. So I'm going between -10 and +10 right now, and hopefully that kind of looks familiar to you, that little domain restriction, all right? So you can see pretty easily, I think, that we do not have a one-to-one function, okay? So what I want you to do is come down to line 5, Mine's not getting down to line 5. There it is. Okay. So I want you to put like y equals, I don't know, put a letter there, A, and it'll make a slider, hopefully. No, let's pick a different letter, like y equals C. Does it let me do that? Oh, why is it putting that on there? Well, I know what it's doing. I don't know what it's doing. What the heck's it doing? Let's put like y equals 3 on there. I thought I'd make a little slider and move it up and down, but every time I put like a letter there, it's not saying I got a slider. So let's put like y equals 0.5, okay? You can see that the green line, oh, there it goes. That's weird. You can see that this line right here is touching in more than one spot. I don't want a red line. I want a green line. Okay, it's not changing to green. This doggone thing's in my way. I don't know what the heck that is. So here we go. Come on, go green. There we go. Okay, sorry. So now, as I move this green line around, you can see that it's crossing in more than one spot. 1, 2, 3, 4, 5, 6, 7 spots. That means that my inverse function would not be a function, okay? So let's check this out. Let's change the x and the y. So where the x and the y are, let's just switch where they're at. X equals sine of y. And you can see that this guy right here, definitely not a function, right? So, you know, if I come down here and I say like x equals 0.5, all right? And I say, yeah, go ahead and make that thing a slider. You can see, let me turn some other stuff off here, that my vertical line is crossing in more than one spot on the purple curve. So this is what the inverse function looks like, because it's taking every one of these x, y's and switching them. So you notice how the domain was like from, you know, negative 3 pi to positive 3 pi, roughly negative 10 to positive 10. And this one, if I zoom out enough, the range is going to go from, you know, roughly negative 10 to positive 10. Oh, because I switched the x and the y, it's not putting a restriction on it. So if I come back up here and if I copy that restriction in there, it's going to, let me see, Control C, Control V, and I got to change, I think, this to a y. Okay, so now, there we go. So now if you look in here, it's restricting it, but it's not restricting it enough, because this purple graph is not a function. So here's what I want you to think about. If we restrict the domain a little bit more, and I restrict it enough to where I have just a constantly increasing or a constantly decreasing function. So let me restrict it all the way over to here, and let's restrict this guy over to here. Now my red function, okay, let me turn the inverse off for a second. And let's turn that stupid vertical line off. We don't need that. Now my sine function is constantly increasing the whole way. So that means that my inverse function is going to be a function, right? I really shouldn't call it an inverse function until I know it's a function. And so a vertical line is only going to cross in one spot on this purple colored curve, right? So what do we have to restrict it to, and is this our only option for restricting it? Like, since the sine function keeps on going, you know, forever and ever and ever, could we come up with a different restriction? Could we go from like a high to a low spot, right? Yeah, let's check that out for a second. So if I go over here and I go from a high to a low spot, constantly decreasing function, I'm covering the entire range. I'm going from a 1 to a -1, right? And so if I look up here, is my inverse a function? It sure is. So technically, mathematicians have, I believe, infinitely many options when we restrict the domain. They chose to restrict it as close to 0 as possible. I mean, like, if we were going to accept this, somebody would then say, well, okay, how about the next, you know, section? That couldn't we restrict it for you know, from you know, whatever this is to whatever the next spot is, to where it's increasing, right? So like restrict it for 1 full pi, and anywhere, well, not anywhere, but just to make sure that it's constantly decreasing or constantly increasing, right? So what they chose is, let's go from negative pi halves. Let me try to get to negative about 1.5, because negative 1.5 is about pi halves, and then positive pi halves would be like positive 1.5. That's the domain restriction that they gave it for the sine function. So let's summarize what we're talking about here. Why do we need a domain restriction? Because we want our function to be 1-to-1. We need a 1-to-1 function so that our inverse is a function. So that the inverse is a function. Put that down, please. Okay, so what is it? Well, how did they do it? So what or how are we going to do that? How are we going to make that happen? That's what I'm talking about right now. What or how? Well, for the sine function, we're going to restrict the domain between negative pi halves and positive pi halves, okay? And let's make those equal to, because we want it to go from -1 to +1 for the sine function. All right. So that restricts, and that restricts the y value. I mean, just naturally, it restricts the y value from -1 to +1, right? So here's what's going to happen. They're going to say something like this. What is the inverse sine of 1/2? Okay, so let's think about our unit circle for a second. Where do we have a y value that's equal to 1/2, right? Where do we have a y value that's equal to 1/2? Well, that happens at 30 degrees, or it happens at pi6. So the only answer that you're going to see on a computer or a Desmos is going to be pi6, because pi6 is between negative pi halves and positive pi halves for an angle. But look, isn't there more than just that? Isn't there more than just that pi6 angle? Couldn't we have said 5 pi6 over here, right? Couldn't the function have popped out 5 pi6? Well, you could have, but then see, it's giving us more than one answer, right? And that's not a good thing if you want a function. You want it to pop out one answer if you're going to have a function. So what they did is they said, no, we're not going to take that one. We're not going to take 5 pi6. We're only going to take that pi6 one because it's between negative pi halves and positive pi halves. All right? So that's why we want that domain restriction. So how about for the cosine or the inverse cosine function? What do we need to restrict the cosine function to so that we have a 1-to-1 function? So here's our cosine function. Right now, my restriction's not good because it's not a 1-to-1 function. If I drew a horizontal line on there, it crosses in 2 spots. So what I'm going to do is I'm going to change it. And remember that their goal was to get it as close to 0 as possible. So they started at 0, and they went out to pi. And when you do that, let me just type pi right here. That gives us a constantly decreasing function, and it's a 1-to-1 function. So if I was going to turn on my inverse function, geez, do I have an inverse function on here right now? I don't think I do. So let's create one. Let's go and just switch the x and the y around. X equals cosine y, and we got to put our little domain restriction there. So I'm going to go Control C and Control V, and I'm going to change this guy to a y, and now we have the inverse function up there. So let me change that to like green or something like that. So the cosine function's here, and this is what the inverse cosine function looks like. And you can see it's a definite function. Vertical line test passes. I've got a 1-to-1 function for my original function. And let's try something out here for just a second. Let's see what the computer would do if I type y equals inverse cosine. So you go shift up like the number 6, so shift 6 gives you that little exponent. Put a -1 up there. It's not really an exponent, that's just notation. I'm going to arrow to the right just so I get out of the superscript. Notice I avoided the word exponent. It's just notation up there. And so I've got my y equals inverse cosine graph, and it's right on top of this graph, so you can't see it, and it's the same color. So let me change it to red. Do you see how the computer naturally restricts the inverse cosine function to that domain restriction? So that's what I'm trying to point out. Boy, it's a lot for our minds to get around this whole domain restriction idea. So as you're trying the homework problems today, I want you to see if you can pay attention to that. See if you can figure out that idea. You're probably going to need to look at some examples. You know, there are examples that they provide you in Pearson, and you guys do a great job with that. So good luck with the homework. I know you can do it. You know I care about you, and I think you're fantastic. So thanks for watching my video.